Good evening. I'm Calvin Joseph, and I'll be conducting your problem solving and doubt clearing session for the week 4. And today we'll be discussing mainly about AC circuits, where the voltage source, the current source, they are sinusoidally varying, or they are functions of sine, etc. We will be considering them and how to solve the circuits which have these sine waves as power sources. And so I will start. Are you guys able to see my screen?
Yes, sir.
Yes.
Okay. Yeah. So if you have any doubts, anything you can ask me, like which are the areas where you're having questions and doubts. So one question. So the power which you get at your home, is it AC or DC?
AC.
AC. Okay. And your mobile, your laptop, they work on AC or DC?
DC.
Okay, then why do you give AC? Anyone has any idea?
That AC which we get from the supply into DC, right?
Sorry? I couldn't hear actually.
Mobile phone charges, they usually convert that AC power into DC, right?
Okay, yes, yeah. Okay, correct. So your mobile phone and all has a rectifier which converts AC to DC. Okay, so we'll not get into all those things, but just as a broad area, the power or voltage supply which you get at your home is AC power. Okay, it is AC. So your fans and all, they get power from AC. Even your computer and laptop, desktop also, they have a stage which converts that AC power to DC, and that DC power goes and charges your battery or powers your electronic device. Okay, so that's why we will just consider AC circuits right now. Now, can anyone tell me what did we do last time? Does anyone recall?
We solved few transient response problems.
Okay. And to solve that, what did we needed knowledge of what?
Differential equations, we solve
Yes.
differential equations to find.
Yes, correct. So we needed knowledge of differential equations. So if I have a differential equation, what are the steps which I should follow? Suppose I have a differential equation. Okay, let me draw the circuit itself. Suppose this is my source. This is my inductor. This is my resistor. This is IN. So how will I solve this circuit? How will I do KVL over here? How will I apply KVL?
So V that is equal to Ri plus L di by dt.
So Vs is equal to Ri plus L di by
Plus L di by dt.
yes. Okay. So this is your thing. So for solving this, what is the order of this differential equation?
First order.
First order.
Why?
First order.
No, but why?
Only derivative term, one term.
Okay, only one
Energy
derivation.
storing element is only single energy storing element.
Okay, because there's only a single energy storing element, that is why it is a first order system. Okay, so if we will solve this KVL equation, then we will get what you say the solution. Okay, and another point I'd mentioned, when you're solving circuits and there are differential equations. So for a capacitor, what variable to consider? I'd mentioned it last time.
Voltage.
So for a capacitor, you will consider the voltage across a capacitor, and for an inductor, you will consider
Current across.
the current flowing in the inductor. Okay. So these are helpful while solving sums, when you must note down which one is to be used. Okay. So when I solve a differential equation, I have two solutions. One is I will get an auxiliary equation. I will get an auxiliary equation and I will solve that auxiliary equation. Okay, for this, what will be my auxiliary equation?
dA by dt equal to, sorry, dA by dt plus R by L.
Okay, so what happens is this external forcing function or this external supply is not considered. It just becomes L di by dt plus Ri is equal to 0. What do? We replace this d by dt by the differential operator d, and we get L into d plus R equal to 0. This is my auxiliary equation. Okay, this is my auxiliary equation. Then my complementary solution, that is my IC of t, will be equal to the root. What is the root of this equation? What is the root of this?
L by R, minus L by R.
So this root is d is equal to minus R by L.
Sorry, R by L.
So the solution of the auxiliary equation will be some constant, assume A, into e raised to minus R t by L. Okay. Is this clear?
Yes.
Yes. And for my steady state, or the forced response, will be 1 upon LD plus R into whatever this Vs. This Vs, okay? So how will you integrate this? How will you solve this?
If Vs is a constant, we can just substitute d is equals to 0.
Okay, but if it is not a constant?
Then substitute e power whatever the thing is, minus into integrated.
Okay, if it is not a constant, it will be, first of all, we will make it better. We will write a 1 upon d plus R upon L into Vs upon L. Okay. So this I will write it down. When you solve it, it will come e raised to minus R t by L integration of e raised to R t by L into Vs upon L into dt. Okay. So when you solve this equation, then you will get your forced response. So any doubts in this?
No.
No, sir.
Okay. Yes, so Neetu, Raga, Ganapati, okay, all of you. So you guys can be active. Okay. So then, you tell me, in an inductor, this is the voltage across the inductor, and this is the current flowing to the inductor. So what is the relationship between the voltage and current in an inductor?
VG
Sir,
Mhm.
V
Sir,
ID.
V that is equal to L di by dt.
Yes, sir. L di by dt.
Okay, L
Yes.
di by dt.
Yes.
Okay, and so the current leads or lags?
Lags.
lag
So the current
if you're
lags
taking it to equal to
by 90 degree, right?
90 degrees.
Okay. Okay, then one more question is, so we have an inductor. Assume we have an inductor. It is connected to a voltage source. Okay, voltage source Vs, which is equal to Vm into sine omega t. Okay. What is omega? Is the omega is 2 into pi into f. So for to your house, what is the frequency of the sine wave which comes to your house?
So 50 hours.
50
50.
Hz.
Okay, so it will be 2 into pi into 50, that is 100 pi. Okay, so just assume this is my Vs, this is my VL. What will be my inductor current?
I equal to C in 1 by C into, sorry. I equal to 1 by L into integral of V dt.
So my I will be equal to 1 by L integration of V into dt. Okay, so what will it be? So my I of t is equal to 1 by L integration of, what
Integral
is
of
my V?
Vm sin omega t. Vm sin omega t.
Sine omega t
T
into dt. Okay.
dt.
So I of t, see Vm is a constant, it can come out. That is Vm upon L. What is the integration of sine omega t?
Minus cos omega t.
Okay. Vm upon omega L into minus cos omega t. Okay. So I of t is equal to minus Vm upon omega L cos omega t. So any doubts?
No.
Now,
No, sir.
okay, how will I write cos omega t in terms of sine omega t? This is coming in cos, but I want it in terms of sine. So what will I do?
Ninety minus theta. 90 minus
90.
sin 90 minus omega t.
So see,
Sin
sine
of
minus omega t is equal to cos omega t, right?
yes, yes.
So what I do, I write I of t is equal to minus Vm upon omega L sine of 90 minus omega t. Okay. But why there's a minus sign? I don't want a minus sign. So what is sine of, what is minus of sine theta? I can also write it as sine of minus theta.
Omega t minus.
So if this is the relationship, so I will write I of t is equal to Vm upon omega L sine of, I take the minus inside, so it gets inverted. So it becomes sine of omega.
Omega t minus 90.
Okay. So why did I go through all this pain? I did integration. It's difficult. I found it in terms of cost, but then I forcibly told you guys you must make it in terms of sine. Why? So if you see the voltage across the inductor, it is equal to Vm into sine omega t. Okay. And if you see the current through the inductor, it is also have in terms of sine. omega t minus 90. So based on this, I can say that my inductor, the current is lagging the voltage VL by 90 degree. Okay. Any doubts?
No, sir.
So if you want to know what is the phase difference, okay, so this is the, so 90 degree is the phase difference. It is the phase difference between the voltage and the current. So now let us go to another circuit. Suppose I add a resistor also. This is my Vs, this is my resistor, this is my inductor. This is a current through the inductor, because I told when you're solving, consider the inductor current as the variable. Okay. So how will you solve this one? What is VL over here? Okay. So you apply KVL like how we did. Okay. You get Vs is equal to R into I plus L into di by dt. Okay. Any doubts in this?
No, sir.
No, right? So now we have to solve this, right? So to solve this, what will we do now? This is our first order equation. Okay. There is another easier method also is there. So let me use that method. Let us say this is, I will rewrite it as di by dt plus R upon Li is equal to Vm by L sine omega t. Is there any query in this?
No, sir.
Okay. So for first order things, there is this method like dy by dt plus py is equal to q. Then we use that integration factor, that concept. Okay, so I will use that concept. So I will write p is equal to R upon L, and my q over here is Vm upon L sine omega t. All right. So now what I will do is I of t into integrating factor is equal to Vm upon L sine omega t into integrating factor into dt plus some constant of integration c. Okay. Any queries in this? It's audible, right?
Sorry, but yes, sir. Sir, but why are we using the conventional method or the already known method?
Sorry?
Why we are not using the conventional method and using this one? Any specific
So-
reason for that?
This is an easier method for first order things. For first order equations, this is easy method. So I prefer to use this for first order things. Okay. Okay. So
Yes.
I will, my integrating factor is equal to e raised to integration of p into dt. So what is p over here?
R by N.
So it is r by L into dt. So what it is? E raised to
RP by N.
yes, e raised to r t by L. This is my integrating factor. So I get it to be of the form I of t into e raised to r t by L is equal to integration of Vm upon L sine of omega t e raised to r t by L into dt plus c. Okay.
Yes.
So we get I of t e raised to r t by L. Vm upon L is a constant, so I take it out. So it becomes Vm upon L integration of sine of omega t e raised to r t by L into dt plus c. Okay. Now this is a very complex thing to integrate. This is a very complex thing to integrate. But there is a formula, ready-made formula is there for integration. Suppose e raised to a x, okay, e raised to ax into sine bx into dx is there. We can write it in the form of e raised to ax upon a square plus b square into a sine bx minus b cos bx. Has anyone come across this formula before?
No.
No. Okay.
So this method is new for me at least.
Oh, okay. Acha. So, okay. So this is one formula is there. Like, you're doing your first year only, or because this might have been taught in the third semester.
I'm in second year, but I was not taught with this formula maybe.
Okay. Acha. Okay. Okay, just assume that this formula is there. And we'll continue. So this part over here, what is my A? Over here, my A is R by L. And what is my B? My B over here is omega. Uh, can you guys correlate? So my A is my R by L and my B is my omega. Okay. And when I substitute this, I will substitute for sine omega t e raised to r t by L into dt. I will get it equal to e raised to r t by L upon r square upon L square plus omega square into A. What is my A? R by L sine of omega t minus B is minus omega cos of omega t. It comes out to be like this. Okay. Yeah. So that when I take L square to the top, it becomes e raised to r t by L into L square upon R square plus omega square L square into R by L sine omega t minus omega cos omega t. So that becomes equal to e raised to R t by L R square plus omega square L square into R L sine omega t minus omega L square cos omega t. Okay. So now I will substitute this solution which I've got. I will substitute over here. So I will get I of t e raised to R t upon L is equal to Vm upon L e raised to R t upon L divided by R square plus omega square L square into RL sine omega t minus omega square minus omega L square cos omega t plus the constant of integration c. Okay. So L is common. So I will write it as I of t into e raised to R t by L is equal to Vm upon R square plus omega square L square e raised to R t by L into R sine omega t minus omega L cos omega t plus c. So this meeting is a Zoom meeting. It will end in 10 minutes. All right. So after that, I will restart the same meeting. So this is complex maths. I understand, but you'll have to learn this. You can remember all these things if you practice. Now, how will we solve this? This again, I want it in terms of sine omega t alone. Does anyone know the method to simplify this just in terms of sine omega t? Okay. Actually, Google Meet doesn't have that recording option, so I use Zoom. Zoom does automatic recording. Okay, I'll take a cos theta. Okay, I'll take a cos theta, which is given by r upon square root of r square plus omega square L square. And I take a sine theta, which is given by omega L upon square root of r square plus omega square L square. Okay. So what I do is I write I of t e raised to r t by L is Vm upon square root of r square plus omega square L square e raised to r t upon L into r upon square root of r square plus omega square L square sine omega t minus omega L upon square root of r square plus omega square L square cos omega t plus c. So what I have done here is my r square plus omega square. Okay, the recording option I think is for Google Meet, which has the paid version. I don't have the paid version. Okay, so r square plus omega square L square, I write it down as square root of r square plus omega square L square into square root of r square plus omega square L square. So you guys have understood this is r square plus omega square L square. I have written in terms of square root of r square plus omega square L square into square root of r square plus omega square L square. And that square root I have taken inside the bracket. Okay, I have taken it inside the bracket. And I know cos theta is given by this formula, sin theta is given by this formula, and I substitute them. I will get I of t e raised to r t upon L is equal to Vm upon square root of r square plus omega square L square e raised to r t upon L into cos theta into sine of omega t minus sine theta into cos of omega t plus c. Okay. So can anyone tell me what is this cos theta into sine omega t minus sine theta into cos omega t?
cos A cos B minus sin A sin B.
Sorry? So this I of t e raised to rt by L is equal to Vm upon square root of r square plus omega square L square e raised to rt upon L into sine of omega t minus theta plus c. Okay. Because sine of A minus B is equal to sine A into cos B minus cos A into sine B. So here my A is omega t and my B is theta. All right. So we get I of t is equal to Vm upon square root of r square plus omega square L square into sine of omega t minus theta plus c into e raised to minus r t by L. So this is the final expression I got. So can anyone tell me what happens to this term as time t tends to infinity?
e power minus infinity is 0.
0.
It
So
is
in
0.
steady state steady state will be Vm upon square root of r square plus omega square L square sine of omega t minus theta, and this becomes 0. All right. And my theta is given by, okay, so here I have cos theta is r upon square root of r square plus omega square, sine theta is omega L divided by square root of r square plus omega square L square. Okay. So what will the value of theta be? What is theta here? Can anyone tell me how to find it? One is simple. You can just directly say theta is cos inverse of r upon square root of r square plus omega square L square. But a easier method is you just divide sine theta by cos theta. What is sine theta by cos theta?
Tan theta.
Okay. So I write it down as tan theta is equal to omega L divided by r. Okay. So I get tan theta is equal to omega L by r. So I will get theta is equal to tan inverse of omega L by r. All right. So I hope till this part it is clear.
Yes, sir.
So it is a very long derivation. Okay, it's a very long derivation is there. But I just wanted to you guys to understand like how you solve the linear differential equation. And since it is first order, we can use this integrating factor method. And we have used that method and some formulas we have used and we have got it. Okay. So effectively, if you see, your current is lagging by an angle of theta. Your current is lagging by an angle of theta. So if you draw the phasor diagram, you have your Vm. Okay. And your IL. This is your IL. It is lagging by an angle of theta. And how will you get theta? It is tan inverse of omega L by R. Okay.
Yes.
So what happens if I make R to be tending to infinity? What will be the angle of theta? Or a better one is, let me start with a simple one. If I make R tending to 0, then what will be theta?
90 degree.
Yeah, theta will be 90 degree. And that only we have seen in the earlier case, right? If R is 0, then the circuit is fully inductive. That means this is my circuit. R becomes 0 means what? My circuit will become this circuit. And in this circuit, what I got? My current is lagging by 90 degree. So we will start solving the first sum. Okay. So this question is there. How will you start solving this sum? Can anyone give any idea, hints? What would you do if you saw this question? How will you start solving it? So how many sources are there in this question?
2.
2. Okay, which and all?
Voltage source and a current source.
Okay. So what is the frequency of the current source? What is the frequency of the current source?
Three hundred by 5.
No, current source. Current source, the frequency is 600 radians per second. Okay, and the frequency for the voltage source is equal to 300 radians per second. Okay. So in this circuit, can we apply the phasor concept? Hello?
Yes, sir.
Okay, what is the phasor concept? What is the phasor concept? Can anyone tell me? What is a phasor?
The angle between the voltage and currents.
You can't exactly say that. So we use a phasor. When do we use a phasor is if the sources and all these things are sinusoidal. So all my sources are sinusoidal. Okay. I will consider it is in steady state. and the sources have the same frequency. Only in that case I can apply the concept of phasor. Otherwise, I cannot apply the concept of phasor. Okay. So now I understood I cannot apply the concept of phasor. Now I have to use some other method. So does anyone know what is superposition theorem?
Yes, sir.
What is it?
Individually sources acting alone.
Okay, so let me apply superposition theorem. Okay.
One source is acting alone or another source is deactivating.
Okay. So let me consider that only this source is acting. Then what will be my circuit?
Current source deactivate.
Okay, so I copy this. I will consider only the voltage source. Okay, only voltage source I will consider. And this they are asking to find out the voltage across the capacitor. Okay. So then my circuit will become like this. Okay. So the current source acts like an open circuit. So how will you find the voltage across the capacitor now?
KVL at the first loop.
Sorry. Okay, we will find
KVL
KVL. Sorry, you told KVL, right? So you apply KVL. So this is the current through the inductor. So it becomes
RC series.
becomes 60 sine of 300t is equal to L di by dt, that is 21 into 10 to the power minus 3 di by dt plus the voltage across the capacitor. Okay. Or I'll write in better terms. Let me write it like this. Any queries still here?
No, sir.
So okay. Now what is my capacitor voltage in terms of the current? VC is what?
1 by C.
1 by C
Integral of I dt.
integral of I dt. Okay. So if I substitute over here, I will get 60 sine of 300t is L di by dt plus 1 by C integral of I into dt. So I will differentiate once with respect to time because I want to get rid of the integral term. So I will get it like this. It will be 60 into 300 into cos
Into
of
cos of
300
300.
is equal to L d2I by
This
dt
square. dt
plus
square.
I of t upon
Yeah.
Okay. Okay. So I will get it to be of the form. What is 60 to 300?
18,000.
Okay, 18,000. So this is 18,000 cos 300t is equal to L d2I by dt2 plus I of t upon C. So I will get it of the form. Okay. So this we will also simplify it further. d2I upon dt2 plus I of t upon LC is equal to 18,000 cos of 300t. So this is another differential equation, all right? So what is the auxiliary equation for this? Okay, so I have to solve this differential equation. This differential equation has two parts. It has one complementary solution, which is that part corresponding to e raised to minus something. Okay, and one it has the particular integral or the steady state one. In this sum, we are interested in the steady state solution. So we get, what we do is, this is actually d2 plus 1 by LCI of t is equal to 18,000 cos 300t. So we have to substitute that. So we get I of t is actually equal to 1 by d square plus 1 by LC 18,000 cos 300t. So what is the solution for this? How will we solve it? So in this case, we have to replace d square is equal to minus of 300
A
square.
square.
Okay, so I of t we get to be equal to 1 upon d square is minus of 300 square. What is the value of L? 21 millihenry, and the value of capacitor is 8 millifarad. So what is LC? What is the value of LC? Suresh Ragan Rajaganapati Naveen, what is the value of LC?
168 10 to the power minus 6.
168 into 10 to the power minus 6. So I will substitute the value over here. So what is 1 upon LC will be? It will be 5952.38 into 18,000 into cos 300t. This comes out to be, what is this? What is the value that comes from this?
Particular integral.
Sorry?
Particular integral of steady state.
But what's the value which comes out? this comes out to be actually minus 0.2141 cos of 300t. Did you guys get the same thing? Suresh, Bhavna, Bharat, did you get the same value?
Yes, sir.
Yes.
Okay, so what will be now my VC? My VC of t is equal to 1 by c integral of I of t into dt. So my VC of t is equal to 1 by c. What is c?
8 by
Okay. So what will be the solution of this? Okay, so we will do it slowly. This will be 1 upon 8 into 10 to the power minus 3 into minus of 0.2141 into what is the integration of cos?
Minus sign.
Integration
The
of cos is
sine,
sine.
sine,
It will
sine
just
theta.
sine. Sine 300t
by 3.
by 300. Okay. So my VC of t will be equal to how much?
0.089.
0.0892 sine of 300t. Okay. Any questions?
No, sir. But that we only took that particular integral, right?
Yes, yes. Because we are considering steady,
Natural response. Yes, sir, continue.
we are considering steady state, so we have done that. And why we are considering d square is equal to minus a square is because that's the method where if we study linear differential equations. When it comes to cos or sine, what they do is replace the d square by equal to minus a square. Okay.
Yes, sir, that is
Mhm. Yeah. Okay. So this is the VC of t because of only the voltage source. Now let us see what will happen because of the current source alone. If only the current source is acting. If only my current source is acting, how will the circuit appear?
voltage will short circuit.
Yeah, so it will be short circuited. Okay. So what will be the voltage VC over here? Hmm? So if you see the circuit, current over here is same as the current over here. Okay. And that current gets divided by the law of current division. So we can write by applying KCL. We apply KCL over here. We will get the current entering into this node is 2 sine 600t. It is equal to what? It is equal to the current leaving the node, that is your IL, plus the current leaving here through the capacitor, that is IC. Okay. Now, we know this is for an inductor, VL is equal to L DIL by dt. So this implies my IL is equal to 1 by L integration of VL into dt, right? And what is the voltage across the inductor? What is the voltage across the inductor? The voltage across the inductor is same as the voltage across the capacitor, right? Because they are connected in parallel. Yeah. If there's only a single source, you can use the frequency concept. Okay. So VL is equal to VC. So what do we get? Okay, so we'll get it as the form 2 into sine 600t is equal to 1 by L integration of VC into dt plus C dVC by dt. We get it in this form. So we differentiate with respect to time. We get it of the form 2 into 600 into sine 600t is equal to 1 by L into VC plus C into d2 VC by dt2. So again, for this one, we write it of the form d2 VC upon dt2 plus 1 by LC VC is equal to 2 into 600 by C into sine of 600t. Okay. That gives me, so when you solve this, for all this, for the particular integral, we get it of the form VC of t is 2 into 600 by C upon d square plus 1 upon LC into sine of 600t. Again, over here, what I do is I replace d square to be equal to minus of 600 square. So can anyone tell me what will be the values? This is 2 into 600. The capacitance is 8 millifarad. So 8 into 10 to the power minus 3 divided by d square is minus 600 square plus 1 upon L is 21 millihenry, right? L is 21 millihenry. So it is 1 upon 21 into 10 to the power minus 3 into capacitance is 8 millifarad. So 8 into 10 to the power minus 3 into sine of 600t. So what is the value of this? So what is the value of the denominator? First tell me what is the tell me what is the value of the numerator. Hmm?
1,50,000.
1 minute. Yeah, 1,50,000. And what is the value of the denominator? That actually comes out to be minus 354047.62 into sine of 600 t. That comes out to be equal to minus 0.04236 into sine of 600 t. Is there any query in this?
No, sir.
Okay, so this is for the case when the current source is only active. And for the case when only the voltage source is active, we get VC of this form. Actually, I think there's a mistake over here. There's a mistake. So this should be 18,000 divided by L. The L which I should divide both sides. So this becomes divided by L, divided by L. So this also is divided by L. So this will be minus 0.2141 divided by L. Okay. So that let me consider this also. So it will come divided by L over here. So this value I have to divide by L. So that comes out to be L is 8, L is 21 millihenry, right? Into 0.0892. Okay, so this comes out to be minus 4.2476 sine of this comes out to be minus 4.2476 sine of 300 t. Okay, so there's an error. I had forgotten to divide by L. So that I've included now. So then my total voltage will be this plus this. This will be a total voltage. So my output voltage finally will be Vc of t is minus 0.4236 sine 600 t plus, it is minus actually, minus this 4.2476 into sine 300 t. 4.2476 into sine of 300 t. Okay. So we have gotten it like this. Why there's no phase shift, right? 1 minute. Just 1 minute, I'm checking. Okay, we have made a mistake. This should be cos actually. So this comes out to be like this. Okay. So there's the error actually. I made a mistake. Is that clear now? Okay, so we'll go to the next question. We'll consider this question. Okay, so what do these voltage, what these are what? These are voltage sources or current sources? These are voltage sources or current sources?
Voltage sources.
These are voltage sources. And what, and is the frequency given over here?
Theta is
So over here, frequency is not needed. Okay, frequency is not mentioned also, and frequency information we do not need. So because they have not mentioned, it means all the voltage sources have the same frequency, and there is a phase shift between the voltage sources. Also, the impedance is given. One is minus J100, one is J100, one is 100 ohm. Okay, so this is the voltages are given. So if I want to find I1, I2, and I3. Can anyone tell me what would be a simple method to do that? Should I apply KVL or KCL?
KC.
KCL. So if I apply KCL, I will let this node denote this node by voltage Vx. Okay, let it be a voltage Vx. Now I will first find the voltage Vx and then I will find I1, I2, I3. So I apply KCL. I get Vx minus 150 angle minus 120 by minus J100 plus Vx minus 150 angle 0 by J100 plus Vx minus 150 angle 120 by 100 is equal to 0. Okay. I have just considered the currents are going out of this node and I have written this equation. All right. Now, I want you guys to remember that if you are giving GATE or all those exams, you will not get the scientific calculator. You just get a normal calculator. So how will you solve this? Because in those calculators, the complex variables or complex functions are not allowed. They are not enabled. So how will you solve such a thing in such a case? So have you guys heard of Euler's theorem? Okay, or how do you represent 150 angle minus 120? How do you represent it in terms of its in terms of this Cartesian coordinates? This can be written as 150.
X is,
Yes, someone is saying?
X is R cos theta.
Yes. So this will be written as 150 cos of minus 120 plus j of 150 into
R
sine
sin theta.
minus 120. Yes. So that becomes, what is 150 cos minus 120? What is 150 into cos of minus 120?
Minus 75.
This is minus 75. And what is 150 into sine of minus 120?
Minus 129.90.
Oh,
J.
it can also be written as j, wait, 150 into sine of minus 120. It can also be written as minus 75 root 3 into j. Okay. Or as you said, 129.9. So this is how, when you have it in terms of this, you have to represent it in terms of these values and solve. If you do not have if you don't have that Casio calculator in GATE exam, etc., and you want to solve such example sums, then you should be able to decompose this into this format and then solve the sum. Okay. So then I will write it down as Vx plus 75 plus 75 root 3j upon minus j 100. Okay. Okay, actually, I forgot to add something. There's an easier method. What we will do is, let me go from here. Okay. So this part is just like some addition, just something which I've shown. Okay, what you will do in case you want to decompose this number. So before doing that, you will go for some other thing. Over here, the denominator is minus j100. Over here, the denominator is j100. Over here, the denominator is 100. So when you know such things happen, what do you do is you multiply it by the complex conjugates, right? You multiply by the complex conjugate. So suppose this is here. It is Vx minus 150 angle minus 120. This is minus j100. I multiplied by j100. Okay. So then the numerator also I should multiply by j100. Then a complex conjugate of j100 is minus j100. So I will multiply it by minus j100. So this is j100 into minus j100. Okay. And this 100's complex conjugate is 100 only. So this will be Vx minus 150 angle 120 divided by 100 into 100. This is equal to 0. Okay. So what I have done, I had these things. The denominator was not common. I understood if I multiply by the complex conjugates, then I'll make the denominator to be common. So I multiplied both the numerator.
So in the last term, 100 in the numerator will answer.
Sorry.
Last term, there will be 100 in the numerator.
Oh, yes, correct. It will be 100 will be over here. Okay. Now I'll multiply. So the denominator will be common because suppose you see j100 into minus j100, that becomes 100 square into minus 1 into j square. That will becomes 100 square is 10,000 into minus 1 into minus 1. So that again is 10,000 only. Okay. So that's how the denominator is common. It is 10,000. Now, so now I will multiply this in the numerator. So this becomes Vx, 100 Vx into j. Then minus 150 into 1000 into 100, so 15,000 into angle of minus 120 plus 90 divided by 10,000. Is there any doubt in this part? Why I did minus 120 plus 90?
Yes, sir.
J value.
Sorry, J value is 90. Yes, correct. Then this becomes minus 100 Vx into J. Then this is 15,000 J divided by 10,000. Okay. The next one becomes 100 Vx minus 15,000 angle of 120 divided by 10,000. This is equal to 0. So since the denominator is common and over here it is 0, I can cancel the denominator. So I will get 100 Vxj minus 100 Vxj plus 100 Vx minus 15,000 angle of minus 30. Then this is plus. How is it plus? This will be minus. No, minus J minus J, so it's plus. Sorry. So this will be plus 15,000 J minus 15,000 angle 120 is equal to 0. Okay. So this and this get cancelled. So it is 100 Vx is equal to 15,000 angle minus 30 plus 15,000 angle 120 minus 15,000 J. So this becomes 100 Vx is equal to 15,000 into 1 angle minus 30 plus 1 angle minus 120 minus J. So 100 and 100 gets cancelled. So Vx is equal to 150 into 1 angle minus 30 plus 1 angle minus 120 minus J. So how will you solve this?
Again by converting into Cartesian.
So this again I have to convert. So this will become cos of minus 30 plus J of sine of minus 30 plus cos of minus 120 plus J sine of minus 120 minus J. So what will this be? What is cos of minus 30?
Root 3 by 2.
0.866. And what is cos of minus 120 plus cos of minus 120?
0.366.
So the real part becomes 0.366 and the imaginary part is sine of minus 30 plus sine of minus 120 minus 1. That becomes, so this becomes J of minus 2.366. So this is equal to 150.366 minus J 2.366. So what will be its value in the polar form? In the polar form, it will be 150 into square root of 0.366 square plus 2.366 square into angle of minus tan inverse of 2.366 divided by 0.366. Okay. what we get?
Magnitude 359.
Okay, actually there was an error. Let us just see where is the error. Okay, this actually is one angle plus 120. Because here also it is a plus. Sorry. This is 120. This plus 120, this is also plus 120. This also is plus 120. So this will actually be, this is correct. This one is wrong. Imaginary part is wrong. What is sine of 120? The sine of minus 30 minus 1. Yes, so this will come out to be j minus 0.63397 minus j 0.63397. So this will be modified. Point 63397 tan inverse of minus angle this angle of minus tan inverse of 0.63397 divided by 0.366. So can you calculate this and tell me what it will be?
Magnitude 109.805.
Correct. An angle
minus 60.
sorry.
Minus 60.0.
Yeah, it is minus 60 degree. Okay. It is minus 60 degree. So this is my Vx. Now I have found my Vx is equal to 109.805 angle minus 60 volt. Now I want to find my I1, I2, I3. So let us put this over here. So what is my I1? My I1 is equal to, it is 150 angle minus 120 minus my Vx upon minus J100. Is this clear?
Yes.
So what will be this value? Okay, I'll solve for one. The remaining you guys can solve. So you guys can solve for I2 and I3. You guys will solve it for that. Let us solve for I1. So I1 is equal to 150 angle minus 120 minus 109.805 angle minus 60 divided by minus j into 100. Okay. So this I will write it down as, let me write it down as 150 into cos of minus 120 plus j sine of minus 120 minus 109.805 cos of minus 60 plus j sine of minus 60 upon minus j100. So what will be the real part? The real part will be 150 cos of minus 120 minus 109.805 cos of minus 60. This is the real part. And the imaginary part is plus j sine of minus 120 into 150 minus 109.805 sine of minus 60. So can anyone solve and tell me what is the real part?
Minus 107.
Let me see.
Sorry, this is wrong.
It comes out to be minus 129.9025. Can someone check it?
Yes, this is correct. Mine was wrong.
Okay. And what is the imaginary part?
Minus 34.8.
Yes. Okay. So when you solve this, what do? You multiply with a complex conjugate. So this becomes 129.905 minus j 34.80 into j 100. That becomes equal to minus j square into 100 square. Or no, let us do a easier method. Why go complex? So how will you represent this in terms of magnitude? So this is equal to minus divided by minus j into 100. What will this be represented in terms of magnitude? This can be represented like this, no? 129.9025 square plus 4.8 square into angle of tan inverse of 30.8 divided by 129.90. Can you calculate and tell what this will be? Okay, mute.
Minus 134.48.
Uh,
Minus 134.48.
134.48, yes. Huh? Suresh.
Yes.
Mute. Noise is coming. Okay.
The angle is 14.99 of 15 degree.
How much?
14.99 or 15 degree.
Okay. 14.9 or 15 degree. Okay, 15 degree. Okay, this minus and minus get cancelled, and this is J 100. So this becomes equal to 1.34 angle of 15 minus 90. That is 1.34 angle of minus 60 ampere. Is there any doubts in this?
I have a doubt. Actually, how is that J becoming 90 everywhere? Even in the previous thing, we just took plus 90 there.
Yeah. J we take it as 90, yes. See, J
How do we do that? We just
J is
simply
actually angle 90.
Oh.
This is, then I can do it.
Yes, sir. Yes. Now it's fine.
Okay. Yeah. So this is how you do for I1, I2, I3. Also, you can follow the similar procedure. So is there any other doubts, like all others are not answering or asking questions? Tarun, 2 times you have joined. Neetu, Bharat, Rajagan, Apati, Akash, Suresh Babu. Let me know where you're facing issues.
Angle 50,
Yes.
15 minus 90, no, sir. That is
Uh-huh.
15 minus 90.
Yes, that is minus. Oh, then minus 75. Sorry. Yeah, correct. Minus 75. Thank you. So we have done this. We'll go to the next question.
I mean, is there any way to solve these things very fast? Looks like some theory derivation kind of thing. It is taking too long time for us, right?
Yeah. So actually, can you see my calculator here?
Yeah.
Okay,
We can see it.
Yeah. So if you use this calculator, you can do it fast, right? You can go, let me.
But in NPTEL, they are not allowing these kind of calculators, and the calculator is not supporting.
Yes. That's why I'm going through this long method. If I use this calculator, it will take only 2 minutes or 3 minutes. That is why I'm solving it step by step so that you guys know what is the alternative method. Okay. Okay, tell.
Oh, they are allowing or not, sir?
They are not allowing.
That is why I'm telling in terms of sine and cosine, because cos and sine you can do it. And also see, the issue is not that it will be like you will solve this for 10-15 minutes and then you're stuck. Okay. Means you can solve it in 10-15 minutes and then you will get like around 6 questions. There are some 6 questions. So it's not like you're spending this much time only to solve one question. It is 6 questions you're solving. You're solving one question which has 6 sub questions. So that will be like, if you spend 10-15 minutes, you're actually effectively doing 6 questions.
Even in exam, it will be like that only.
Yeah.
I saw previous assignments where they just give only 1 mark for the whole equation or something. I was pretty shocked. I see.
Oh. No, it will come like this because you get actually one question. If the question is big, like these questions are big, you'll have one question with some many subsections also.
Even in the exam, it's same, right? Then it's fine. Otherwise, it's going to be a tough task.
I'll have to check because I had seen for a previous different subject. In a different subject, they had 2-3 questions, 2-3 sub questions for one question. For this one, I'm not checked actually for this subject.
Okay. If 3 to 4 marks are allotted for these steps, then it's fine. Otherwise, this is a very tough part.
Yeah. So here, if you make any mistake, it goes completely wrong. So
Yeah,
this is
all the 4 questions will be wrong. You'll be losing 4 to 5 marks.
yeah.
And options also not present nowadays for this course.
Yeah, numeric answers and options are not present. Yeah, correct.
Definitely, it will be going to be very tough.
Yeah. It will be tough, but see, all these things you have to only practice. You cannot. There's no shortcut.
Yes, we're not complaining. We're just saying that
Yes.
is the thing we should be doing. It's a tedious process. So that's
Yeah, actually, here also like I have gone slowly and done. If you like learn for faster methods, etc., then you can go like this is an easier method. Like if you have A angle theta, B angle theta 2, you can effectively write it as A by B angle theta minus theta 2. Okay, so such things you can use. So if at all it is A angle theta into B angle theta 2, you just directly multiply AB angle theta plus theta 2. This might save some time. This might save some time if you use this method. Okay.
what is there in between. The operator is plus or minus. Is there anything like that?
Sorry.
Here we have taken A by B, right? A by B and A cross B. If the operator in between them is addition or subtraction, is there anything?
No, see, what this means is suppose this is I have 12 angle 60 divided by 3 angle 45. I can just instead of doing 12 cos 60 plus j12 sine 60 divided by 3 cos 45 plus j sine 45. This is headache, right? Instead, I just do 12 divided by 3 is how much?
Yes, sir. Yes, sir. Now, this
4
is fine, yeah.
angle 60 minus 45. This is 4 angle 15, right? Then I can make this 4 cos 15 plus j 4 sine 15. Okay. This is later, but this is the main thing. And many times they want your answer to be in this format. The amplitude and the angle phase difference. So that time this is useless. You want it in terms of this format. So you have to see like that.
Yes, sir.
Also, you guys have not learned linear differential. You have not learned Laplace transform. Once you learn Laplace transform, it is very useful because these differential equations is like a headache to take it, solve it, do it. Laplace transform converts the differential equations into algebraic expressions. So once you do that, it makes it quite easy. You take the Laplace transform and you take the inverse Laplace transform. So I personally,
Continue.
so I personally prefer solving sums using Laplace transform. They make it very easy for me.
So even these kind of sums, it can be solved using Laplace transform, right?
Yeah. These also sums can also be solved using Laplace transform. Okay. So where was the question? Okay, we'll go to the next question. Final question. So this is my question. They are saying you must tell me the RMS value Okay. If they tell RMS value, it means they want the steady state right now, steady state. If it is steady state and there is only one frequency, then I can use the concept of phasor. Okay, I will use the phasor concept. Now, what is my impedance of my capacitor XC? What is that value of that impedance? What is the formula?
1 by omega c.
It is 1 by j omega c. Okay, don't forget j.
Yes,
So
yes.
that will be 100 into 4 into 10 to the power minus 3. So what is it? It will be minus j 2.5 ohm. Have you guys calculated and verified?
Okay, sir.
What is my XL? What is my impedance of the inductor?
J omega L.
J omega L. And the value?
2.5 J omega.
It is
I
J
mean
2.5
2.5
ohms. Okay.
ohm.
So now what you can understand by this? If you do XC parallel XL, what will be the value of the impedance? What is XC parallel XL?
2.5 into 2.5 by 2.5 plus 2.5.
Minus J 2.5 into J 2.5. Don't forget J. It is important. Divided by minus J 2.5 plus J 2.5. Yes. So that is infinite. So this effectively is infinity. So
Parallel combination.
yes, so the parallel combination of capacitance and inductance is infinity. The impedance is infinity. So it means that the current which is flowing from here will flow from here and will flow like this. Okay, this will act like an open circuit. This entire thing will act like an open circuit. So my circuit, I can write it down simply as, so let us sink in a bit, okay? This impedance is equal to the negative value of this impedance. So they effectively, these two, their combination, parallel combination as a impedance of infinity. And so my current, which is comes from my voltage source, directly goes into my resistor. Okay. So I can write, so what will be my current? What will be this current to my resistor?
150 angle 45 by 50.
Yes.
30 angle 45.
So the current through my
53.
resistor is 150 angle 45 divided by 40 plus 10. That is 150 angle 45 divided by 50. So I do this,
3 angle,
it comes
3
out to
angle 45.
3 angle 45 ampere. Okay. Current across my resistor is 3 angle 45 ampere. Now, can you tell me, assume this voltage is some VR. What is this voltage VR? What is the value of this voltage?
I into 10. IR into 10.
IR into 10. Okay. So your VR is IR into 10. So what is that value?
30 into 45. 30 angle 45.
30 angle 45 volts. Okay. Now you tell me what will be the value of IL and IC?
0.
0.
No.
Open
It
circuit.
was 0.
It is already open circuited. I mean, if it is steady state, then they will be open circuited, right?
What is the voltage across your inductor and capacitor?
VR, whatever the voltage that we are seeing, VR.
Okay. So then what should be the current across your inductor?
Vx by XL.
Yes. So your current
VR.
across your inductor will be your VR divided by XL. That is 30 angle 45 divided by J 2.5. That is equal to 30 angle 45 divided by 2.5 angle 90. So your IL will be equal to 30 divided by 2.5, that is 12 angle minus 45 ampere. Okay. Just believe me, okay, just believe me. I know the voltage across VR is 30 angle 45. That means the current through the inductor will be VR by XL. That I got it to be 12 angle minus 45. Wait, just wait. There's some more we have to see. What is my current in my capacitor? Current in my capacitor is VR by XC. That is 30 angle 45 divided by minus J 2.5. That is 30 angle 45 divided by 2.5 angle minus 90. That is 12 angle 45 plus 90. That is 12 angle 135 ampere. Now, if you add IC plus IL, okay, IC plus IL, what will you get? This 12 angle minus 45 plus 12 angle 135. How much you will get IC plus IL? Or what is the phase difference between IC and IL?
90 degrees.
No. This 180 degree. Your IC current
Oh, okay.
is 12 angle minus
Yes.
IL current is 12
Yes,
angle.
yes, yes.
So what happens is, if this much current was flowing like this much same current is flowing here. Suppose 8 ampere is flowing here at one instant, then 8 ampere is flowing here at the same instant. So effectively the current coming in here is 0 ampere. Okay. Yes, it is 0. It means there's a current flowing here. There's a current flowing here. But the total current at this entering in it is 0. That is why it is acting like an open circuit. Is there doubt still, or this is very confusing still?
Yeah, it is clear.
Again, explains.
Okay. See, we found that XC parallel XL has impedance infinite. That means, let me show again. That means for this impedance is infinity. So the current entering here should be 0. But that does not mean that there's no current flowing here and here. Whatever current is flowing over here, same current is flowing over here. So the current is flowing like this. It is flowing like this. Okay. There, a tank circuit, like a tank circuit. Okay. So I hope this is clear.
So IC must be having some negative sign.
Yeah. Yes. It will have it. No, but the amplitude is positive. No? Amplitude of the magnitude of it is positive. The phase will be different. Phase is minus 45. That's all.
I mean, as per the question, the direction is showing different. So that's why we may need to.
No.
Okay, we may need to showcase only the face. Okay.
Yeah. The phase will showcase whether it is positive or negative. That you don't have to worry. Okay.
So in these kind of problems, we need not worry about the direction of the current in terms of the magnitude.
Not. I don't mean that. In my question, I have IC is given. The direction of IC is downwards. Okay.
Yes.
That
yes.
means that is the voltage across the IC, that is VR divided by XC. I did that and I got it to be 12 angle minus 45. This. See, you must understand this is a AC circuit. AC circuit, what happens? The current is either positive or negative. All right. The current at some time is positive. The current is sometimes the current is going downwards. Sometimes the current is going
Yes.
upwards. Now,
Right.
this is so confusing for us. So for that's why we use the concept of phasor. We consider that one is the reference. One is a reference thing. Another is either lagging or leading. Another is either lagging or leading. So assume this is your this is at your some voltage. Assume this is your voltage and this is your current. Okay. This is lagging by an angle of 45, you assume. So when your voltage over here is 0, your voltage over here is some value. Okay. Then this will be lagging it by 45 degrees. At one case, this will be like this. This will be here. This will be here. Because it is a rotating phasor. It is a rotating thing. It is rotating like this. It is rotating like this. In another condition, this will be like this. This will be like this. Another time instant. Another time instant, what will happen? This will be like this. Your voltage will be like this. This is your current. So this is your voltage. This is your current. This is your voltage. This is your current. This is your current. This is your voltage. So like that, as time changes, voltage will become negative, positive, etc. All that will happen. Current also will become negative, positive. But there will be a relative phase shift of 45 degree. Okay.
Oh, at only one frequency we are talking about, right?
No, only one frequency. Only one frequency. Okay. So if there are any other doubts, you can ask me, or else we'll end the meeting. The meeting will end in 1 minute anyway.